you it is one of the extra credit problems. I did sine double theta. And I derived it for you. I showed you where it came from. And all of a sudden, the final exam for an extra credit problem says, now you derive a formula for sine triple theta. And I want your final answer to have only sine in it. So sine triple theta is equal to, and then you have a formula. And the formula is written in terms of only sine. And I'm not going to do it for you, but can someone tell me how on earth would you start?
Sine 2 theta plus theta.
Thank you. Ignacio, that's 3 theta. I'm not going to do much more for you. Then, who can now tell me what might be the next step in your attempt to get this extra credit? No, tell me now. Sine, look at it. A plus B. Are you kidding? Now you need the sine A plus B formula. Let me do it real quickly, just write down real quickly. Sine A plus B, guys, I think it's going to be sine double theta. Geez. Cosine what? Theta? Don't make a mistake here, guys.
Yeah.
Plus what? Cosine double theta?
Yes.
Jeez. Sine theta. Is that true? I hope I've written that correctly. Then, though, my instructions say don't stop there. I want your final response to have only sine and cosine. Or in fact, just maybe sine in this one, if you can. What else might you do? Now you got to put what here? Sine double theta? Is that a formula?
It is.
So you put what, 2 sine theta, cosine theta? Times cosine theta, you're going to have fun with this. Is there a formula for this? If I want all this in terms of sine, you find a particular one that has only sine in it, clean it up, and at the end have your formula all in terms of sine. Good luck. At least I gave you a hint. So you sort of think about that for an extra credit problem. Now, Shane, on this new handout, tell me what did I have there for the continuation or the closing down of that section?
Establish the given identity.
Okay, now we're going to do just maybe one of these. Tell me what the first one is.
Cotangent theta minus tangent theta
Okay, well, minus tangent theta.
over cotangent theta plus tangent theta is equal to cosine of 2 theta.
Cosine of 2
Cosine
theta,
double theta, yeah.
double theta, like this. Oh, what a workout. I will do this one. If there's others on there, I'm not going to do anything else on that. I'll show you the process here on this one. Guys, I know she did not use the word solve. You're not going to solve this. She says establish. That means show the 2 sides are equivalent. Now, your instructor standing here staring at this. I look at that, I'll say, what on earth? There's no way that all this on the left is identical to this on the right. But that's what they're asking me to show, that the 2 sides are identical. Now let's work on the left. Does anyone have an idea of what could you do on the left to get a start in an approach to try to show those 2 sides are the same? Let's start on the left and work on the left.
Cotangents.
Cotangent can be expressed as, and we're going to step 1, what?
1 over.
Something better than that. I thought you were going to say it.
Inverse tangent.
No, make it too hard.
Oh.
How could I express just cotangent as?
Cosine over sine.
1 over tan, better than that.
Cosine over
Maybe cosine over sine, since I see a cosine over there. Or I could rewrite it like this. What you guys said earlier was true though. Then subtract. Now, is there a nice replacement for that? Sine over cosine. We'll put everything in terms of sine and cosine. Sometimes that's the best. Then my denominator on the left, there's cotan again, which is cosine over sine. Oh, this will be cute. Plus tan again, sine over cosine. Now see this. It's one big reason these universities are accepting SMC students by the tons. Lots of students have been accepted. Guys, still this in the blue does not look like this. Now what would you suggest now in step 2? You guys cleaned up. How are you going to clean this up? Because you get a little partial credit already. I need a common denominator. I need to put these two together with a common denominator. And by the way, the common denominator for the top is sine cosine. Now watch careful, I'm going to do. That means this one has to be multiplied by, if I want that common denominator. This has got to be multiplied by what? Cosine? Cosine. And this one by what? Sine? Sine. Which will give me cosine squared subtract sine squared. All over that common denominator. And guys, that's the top part. Now what are you going to do down here? Same thing. Another common denominator, put those two terms together down there. By the way, it's the same common denominator. Therefore, this has to be multiplied by cosine. Cosine. This is going to be multiplied by sine. And guys, what's on top from the bottom part?
It's
Cosine squared plus
sine squared theta.
sine squared theta. Now that's the bottom. Erase that. Now, whew, so I'm down to here, that's step 2. Step 3, does anyone see something nice happening? Cosine squared plus sine squared is always 1. So I'm down to now saying this. Cosine squared, and we'll rewrite theta minus sine squared all over a common denominator. Where was it? Sine, cosine. I'm running out of board space down here. Sorry about that, guys. All over, let's bring it over here. That's all over, where am I? Down here. Did you guys say this is 1 here?
That's 1, yeah.
1 over sine theta, cosine theta. I don't want to get too messy. Please tell me, guys, all this is over this. What's going to happen? Well, the sine theta, cosine theta cancel.
Yes.
You guys could actually look at that a little bit closer. So I'm left with merely cosine squared minus sine squared. Is that one of the formulas for cosine double theta from that previous work Shane did or read for us? So this is directly one of those formulas, and that's what they asked me to show. So I've established that side was just cosine double theta. Did you guys follow the argument? Oh boy. Okay. I know it got a little messy down there. Are we okay there? Yes? No? So I'll move on. No? Yes? Okay. Shane?
Yep.
Now, that's the establish. Okay, let's move down to the next item. What does it say next?
Oh, there's another established.
Okay, we're gonna leave that one out because I think I did one for you, and I think the other one you can try on your own and see what you get
Cute.
in there.
Half angle formulas.
There you go. As if you didn't have enough to worry about.
Mhm.
Half angle formulas. By the time it's classified the engine, when they half your life's gone. That's all we have to do here. Half angle formulas. Okay, this is closing down. We've already done double angle formulas. We did the sine A plus B, cosine A plus B, all that business, didn't we? The double angles. Now they said don't stop this chapter, finish it up until you do some half angle formulas. Guys, I'm not gonna show you where it came from. I could. I'm gonna just list the formula and show you how to use it. Shane, could you tell us what the sine of 1/2 theta, not double theta, half angle
Is equal to.
looks like?
Is equal to plus or minus
Okay, plus minus.
the root of 1 minus cosine theta over 2.
Beautiful. Now, I could show you where it came from, derive it for you. And I think I listed what, one more?
Yeah, it would be cosine half theta.
Cosine 1/2 theta, half angle, plus minus again, I think, and what was that?
1 plus cosine theta over 2.
Over 2. Guys, those are the ones, Alexandra, just in case you run into the test, tan 1/2 theta, and I don't think I listed a tan 1/2 theta on the sheet.
You did not?
But could you deal with it? Yeah, you place what, sine over cosine, which would look awkward as you know what, but you'd have to, if they ask for it. Those are the only two I'm holding responsible for though, right now. Shane, did I have an example of maybe making use of this?
Yeah, use a half angle formula to find the exact values of
Okay, what was that?
cosine pi over 12.
Oh, whoa, hang on. Does anyone know what pi over 12 in degrees, if you convert it, is? Which I think might be easier in my mind to think of it in degrees here. It's pi over 12. But in degrees, what is that? Is it 15? They're asking to find the exact value, no calculator, of cosine 15 degrees, and you've never seen a 15-degree angle on the unit circle. And use one of these half angle formulas. Guys, when we take half of an angle, what angle would I be taking half of? 5 or 6. 1/2 of, put it right here in a different color so you can see what it is. It's exactly right, half of 30. It's 15. And now I have it written so I can use, oh, she asked me to find cosine. Use the cosine formula. The true guys? Apply the cosine formula. By the way, guys, since pi over 12 is like 15 degrees, it's in quadrant 1. So it's positive. So out of these two signs here, we'll have a positive, of course. Then square root 1 plus cosine of what Ignacio gave me. He gave me pi over 6. You get this color coded up there, put that pi over 6 in there. That was the angle. All over 2. We'll get an awkward looking answer. It'll be a positive large square root 1 plus, and from the unit circle, cosine of 30 degrees, cosine pi over 6 is that right equal 3 over 2?
Yes.
All over 2. Look how awkward that's looking. So far so good? Use a common denominator on the top there. Write this as square root of 2 plus square root 3 over 2 all over 2. Woo! Square root 2 plus radical 3 over what? 4. Is that true? Yes or no?
Yes.
Woo, my class is awfully quiet today. Is it 4?
Yeah.
Now I do a square root. Well, the square root of 4 I can do. That on top is strange as you know why. So I gotta leave the top as, I'm putting up here guys, square root of 2 plus radical 3 all over square root of 4 is 2.
Do we still keep plus minus?
I got the plus because it was plus minus, but we said plus because it was 15 degrees and that's quadrant 1.
Oh.
The original angle is located in quadrant 1, where everything's positive. Look at that. What a strange answer. Merely asking for cosine 15 degrees. And it comes out to be that crazy answer. With the help of a formula. Now, before I leave it, Shane, before I do anything else, can someone in this clever class tell me, if I do not tell you which formulas to use, and all of a sudden you see staring at you on the final exam, find the cosine of 15 degrees, you're gonna say, oh, I saw him doing this with a half angle formula. Take half of 30, 5 or 6. And I got an answer, and that's the answer. Another student may say, Professor, there's another formula I could have used to find the exact value for cosine 15 degrees and not touch that half angle formula. Does anyone have another way that I could have discovered what this is, but approached it differently for cosine 15 degrees? Just out of curiosity. Let's see, Mr. Hahn.
Double unload formula.
Oh, well, 15 degrees is double. Be careful on double what? 7.5? You don't want that.
No,
Not double.
I mean.
Yeah, because if you double, you got double 7.5 to get 15. Yeah, I don't know anything about 7.5. Something easier than that. You're thinking too much there. Daniel.
Cosine of 60 degrees minus cosine of 45 degrees.
Oh, he says, Professor, think of 15 degrees as this. Let me do degrees here, guys. Let me use radians. He gave me 60 degrees, pi over 3. And Daniel gave me what, 45? Was it 45? 5 over 4. Is 60 subtract 45, is that also 15?
But why sine?
Why is it sine now,
Yeah.
isn't it, it's cosine, no?
Oh, is it cosine?
Yeah.
Cosine. Is that true, guys? And then what would he do? He's going to use an entirely different formula. He's not going to touch the half angle formula. He's going to use what? The cosine A minus B formula. Which I'm not going to do for you, but he would use cosine A minus B. Daniel, I love that. You can do that, but when you get your final answer, if you use the cosine A minus B formula rather than the half angle formula, guarantee you, it's going to work. But your answer finally out here by this formula will look nothing like this. It's going to look nothing like this. But they are equivalent. Should I go ahead and show you? Before we get into chapter 7? Let me do it. Mr. Parker, I'll need you here shortly. I'll need you shortly here. Hang on. Help me out, guys. Daniel, here goes. I'm going to use your cosine A minus B formula. That would be cosine what? 5 over 3. Cosine what? 5 over 4. Do not let me mess this up, guys. I think it's a plus sign next. Sine 5 over 3. Sine 5 over 4. Yes or no? That's what Daniel will be using. Put my replacements in from the unit circle. Cosine is 60 degrees. Cosine 5 over 3. 1/2. Cosine 5 over 4. Radical 2 over 2. All from the unit circle. Sine of this, I think it's radical 3 over 2. I hope it is. And sine of this is radical 2 over 2. From the unit circle. Jeez. I got, altogether, guys, radical 2 plus radical 6 all over 4. If you clean this up. Would you guys agree? Is it radical 2 plus radical 6 all over 4 if you clean it up? Daniel, I applaud you, I praise you. I have to give you credit for this. And all of a sudden, Alexandra walks out and they start talking, and Daniel says, I know I got that one. And Alexandra said, oh, what'd you get? I got radical 2 plus radical 6 over 4. And then Alexandra gets worried, she comes back in and says, Professor, I messed up on my final exam. I'll see you during the summer. I said, what'd you do, Alexandra? I got that. They're both correct. They don't look the same. They're both correct. Now, Mr. Park, please tell the class. Let's get to the one this one right here. Where is it? My goodness, I messed up myself. We got this. Would you see what the value of this right here is? Using the calculator. What's that close to?
It's like 0.9.
0.96?
96. Yeah.
Now, Mr. Park, okay, see what this is.
Um,
This one.
okay. Just punching in. Sorry. It's like 0.96. Yeah. It's
See, same value?
yes, it does.
They're the same. Walk up to one of these math professors and ask them. Most of them would respond with this. I would. This is the easier one, I think. Radical 2 plus radical 6 over 4. The way we did with that formula that Daniel gave me. And then this one is really strange. As a math professor, you're a math professor. You think, my goodness, are these two the same? They look so different. They're the same. He confirmed it by using the calculator. So that's not dependent, that will not depend upon what formula you use to find it. Shane, I think that's it, is it? Please tell me it is.
We've got another cosine of the half angle.
Oh my goodness.
Sorry.
Cosine 1/2 theta,
Yeah,
and then they're asking to find what?
well, it's saying find the cosine of 22.5 degrees, which is 1/2 of 45.
And then that's it?
That's it for chapter 6.
Oh, thank you. Chapter 7 will be so short and sweet. Okay, cosine of, you said 22.5? Did I have it in degrees? Okay. And if I was going to find you guys, this is cosine of 1/2 of 45. And then we would have to turn to, was this a cosine? Did I just do a cosine also? It wasn't a sine. Was it a cosine again?
They're both cosines, yeah.
Okay, but, oh, darn, she gave one that sine. Okay, I'm gonna use this formula again, guys. By the way, that's 22.5, it's in quadrant 1, so I know the answer is gonna be a positive. So it should be equal to square root 1 plus cosine 45 degrees all over 2. 1 plus cosine 45, guys, I think it's square root 2 over 2, see if I'm correct. All over 2, again, we're gonna get a strange answer. Top part, common denominator, 2 plus radical 2 over 2 over 2. That true? Strange. And you're going to end up with square root 2 plus radical 2, I think it's all over 4, is it?
Yeah.
And thank goodness that 4 is a nice perfect square root. The top is not nice, so I'm gonna leave it. At least the bottom part, denominator, is a 2. And there's your answer. Jeez. Daniel, Mr. Mathematician, I don't think for this one, I don't think you could use another formula. 22.5, I can't think of anything for A plus B on it. Can you guys? Or A minus B? So I think we're sort of stuck with this one. Okay, she says that's it, guys, for that chapter. Is that true? Woo, have we done it? Now, I know I've got just a few minutes. Now, I'm gonna at least do this for you. Chapter 7's a breeze. We gotta get through it. Get through it tonight. So we start chapter 11. Part 1, part 2, part 3, take about 5 minutes. At least set you up. And Shane, did I have this labeled some way here for chapter 7?
Right triangle trig.
Now, right triangle
Yep.
trig. We'll just set you up and we'll take a break here. Now, the author of your textbook, he has 2 versions out. Sometimes my students, when I send out the syllabus and let you know which textbook we're using, you buy the wrong one. He also has a textbook out, the same author, Sullivan, that says trigonometry using the right triangle. That's not us. Ours is trigonometry using the unit circle. Two different textbooks, and sometimes my students will come in with the wrong textbook. But we're going to look at this. Now, to do this and then take a break, here's what I'm going to do first. This, I think every student in class will relate to what's going to happen here. To make chapter 7 a breeze. Let me quickly do this. Not messing up too much. And so we're back to the circle. That's what we're accustomed to. Let's say I have a point on that circle, let's call it a unit circle, and we'll label it X, Y. I will put the radius in on this unit circle. Connect it here, and have it to look like that. This is my radius. We are accustomed to a radius of 1. The unit circle that I passed out to you. Now what am I going to do before we take a break? I want to, on that sketch, to do this. And you guys will remember this from high school. This is the way most high school classes approach tree. Then we're going to drop a perpendicular from point XY down to the X-axis. And form a small right triangle. With, this side is X, this is Y, in the red. That true, guys? Mm-hmm. Now, place theta right in the corner. Now, if this is a unit circle, which I've made a unit circle, if I ask you to express sine theta, you say, Professor, no problem. It's Y. Isn't it? It's a unit circle. Cosine, real quickly, before we take a break, is X. No problem. Tangent is Y over X. This is what we've been working with all this time. And then, of course, the other three. Now we go back to sine theta is equal to Y, which is true. Could I express this Y as this if I wish? Is that still Y? Y over 1? So if I take a close look, guys, I'm saying this side over this. Now, chapter 7 identifies those sides with words. I bet you've seen this back in high school. They call the red one, the side opposite my angle theta. So this is the opposite side. Does anyone recall what they rename or call the X down here in this right triangle? The adjacent side. Some vocabulary. The adjacent side. And we all know what the 1 is representing besides the radius is a hypotenuse of the triangle. Here. So now, can someone tell me another way to express Y over 1, which is Y, using now this new vocabulary? This is the same as saying what over what?
Opposite.
The opposite side, the length of it. Okay, opposite side. And the 1 was representing the hypotenuse. I'll just abbreviate that word. So opposite over hypotenuse. I bet that's where you've seen it if you've had any trick at all. The next one says cosine. Cosine for us is X. No problem, that's X over 1. X is the adjacent side, side next to my angle. The adjacent over again hypotenuse of 1. Tangent, Y over X, the opposite side over the adjacent side. You guys recall this? Okay. Now secant, cosecant, cotangent, easily done. If I ask you now to express, before we take a break here, I'm going to express one of them, guys. If I say, now, what do you think secant would be expressed as using a right triangle? You say, well, Professor, it was 1 over x for us. Now it's what? Yeah, it's hypotenuse over adjacent. In fact, I think it's supposed to be the reciprocal of which one? Cosine. The cosine was this one. So I just flipped it over. Is that true? And you can rename those. Now, if we take a break, I know some students right now are seated. They're saying, this is bringing back some fond memories, Professor. Back when I was younger, and I was back in middle school. You guys enjoy middle school? Oh, I see one head shaking. No middle school. Did you enjoy high school? No high school? Didn't enjoy it? Jeez. Now, before we take a break, some students have come to me. I didn't know this until they told me. They said, Professor, I know what you're doing now. I'm back in middle school, high school. I said, what? They did this. They copied this down wrong. Oh, I'm going to mess this up. I'm going to mess this up. I don't know whether anybody knows where I'm going. I had never heard of this. I thought they were calling me a name when I first heard a student say, Professor, I remember this. My teacher says a good way to remember what you're talking about, Professor, here is SOHCAHTOA. I said, what? I had never heard that word before. I don't know whether it's a word or not. SOHCAHTOA. These middle school teachers are crazy. I said, what does that mean? I didn't know what it meant. They said, Professor, S is for sine, and sine is equal to opposite of hypotenuse. O over H. C, cosine, is adjacent over hypotenuse. And tangent was opposite over adjacent, like we were talking about there, I think. So they said SOHCAHTOA, SOHCAHTOA. I thought they were mad at me and calling me a name. I thought, I'll see you outside. Jeez. Had you guys heard of that before? I had not, but some students and my teacher showed me that. It's a quick little way to remember this. Guys, we'll pick up with that and then try to finish up this chapter 7. Chapter 7 short. Take your 10-minute break, and I'll see you and we'll get this finished up.